Okay, we're going on to look at mean, mode, and median. These are measures of central tendency. That's roughly where half the data will lie. So a central tendency is an average of the middle value of a set of data, is the average or the middle value of a set of data. Okay, so what is the mode? Right, let's go back here for a moment. Right, for example, in American football, the New York Giants players have a mean annual salary, that's an average annual salary of $2.5 million, and a median annual salary of $850,000. Eli Manning, the superstar quarterback, has an annual salary of $8.5 million. The mean salary is obtained, how do we get the mean? By dividing the sum of the salaries of all the players by the number of players. So the average price of an item is, of your shopping, for example, your grocery shopping would be add up all your groceries and divide it by the number of items that you purchase. That would be your average cost per item. Now, we do know, of course, that some things will be more expensive than others. Just like, for example, here on this team, some team members are going to be paid a lot more than others. So, therefore, if there are what's called outliers, that's some people earning a lot more than others on this New York Giants team, well, then that will throw out the middle value or the average, the mean. So there has to be other ways of looking at trying to find the measure of central tendency or the average, depending on, as I said, if you have outliers or other things. So you need to ask yourself which average is more effective is more reflective of the salary that most of the players on the team earn. In this case, the median is probably a better average. So when you have outliers, you'd use the median. Why would you use the median? Because the median, how to get the median, or how do you get the median? You arrange the salaries in order of magnitude, and you're picking out the middle value. So therefore, it would be a better way of finding the average. So in this chapter, you'll become aware of the different types of averages and the dangers of jumping to conclusions when interpreting these numbers. The mode, what is that? It's a set of data. The mode of a set of data is the data value that occurs most often or most frequently in the set. For example, right, the mode here means the most often, the most frequent. So blue is the mode of this because blue is there the most often. It's the tallest of the bar charts there is blue. Right, so there are a number of possibilities for the mode of a set of data. Sometimes there is no mode. Sometimes there is one mode, that's unimodal. Two modes, bimodal, and more than two modes, multimodal. So sometimes, there are several modes, and therefore that's not really going to help you either. So find the mode of the following array of numbers. Right, so for example, 5, 6, 8, 9, 9, 11 and 12. Well, you can see there 9 is the mode because it occurs twice. Okay, number 2, there is one mode here, that's 5. It's there 3 times. In this one here, we have 2 modes. It's bimodal because 5 is there 3 times and 7 is there 3 times. And in the last one, there's several modes. Right, there's 2 2s, 2 4s, 2 6s, 2 8s and 2 10s, right? So that's not going to help us. Okay, given the following data values, find the mode. Well, again, if 10 is added to each data value, then find the new mode. So first of all, to find the mode of what's given, you can see there it's 5, right? Because there are 3 5s. Now, what if I added 10 to all of these? Well, then I'd have 12, 10 and 3 is 13, 10 and 4 is 14, 15, 15 and so on. So now my new mode is 15. So basically, if you're adding a value to each of your original values, well, your mode is just got by adding that additional value, like 10 in this case, to the original mode, which is 5. So that'll give you your new mode, which is 15. If each data value is multiplied by 4, find the new mode. So what do we have? Well, again, we see that the new mode is 20. That's 4 times the original mode, right? So if we add a value to each of our originals, right, how do we get the new mode? We add this value to our original mode. If we multiply each of the original data values by a value, like for example by 4, well then we multiply our original mode by 4. So if each data value is multiplied by 4 and increased by 10, well again, it's the same thing. You multiplied by 4 and you increased by 10. So 4 times your original mode, 4 times 5 is 20 plus add a 10 to it, so you get 30. So your tip there, therefore, is if you have a set of data and you increase each data value by L, the mode of the new data set is also increased by L. If you have a set of data and you multiply each data value by K, then the mode of the new data set is also multiplied by K. And if you have a set of data and you multiply each data set by K and then increase it by L, well, the mode of the new data is also increased. You multiply it by K and you add L. So that's just important to remember. So the diagram here below, right, what does that show? It shows the line plot for a set of discrete numerical data. So what is the mode and why? Right, well you can see there that the mode is 3. Why is the mode 3? Right, you can see there that the mode is 3 because it has the greatest frequency. Draw up a frequency table and use it to find the mode. Right, so if I draw up a frequency table, I have all my values from 0 there over to 11. I put in how many times each one occurs, and you see there 0 is there 0 times, 1 is there twice, and so on. You count 2 is there once, 3 is there 4 times, and so on. You can also find the mode from that, because you can see there the one with the greatest frequency, highest frequency is 4, and what x value gives you that? It's 3. Example 5. The following stem and leaf plot shows the time in minutes that students spend doing an experiment in the laboratory. Right, and again you're asked, how many students were in the class? So you add up all of this here, right? You add them all up, so you have 3 and 2, 5, and 3 is 8, and 2 is 10, 2 is 12, 13, 15, 18, 20. So there are 20 students in the class. What's the mode and why? Well, you can see here, these are all 5s, so with a 3 out here, so therefore 35 is the mode. Why is that the mode? Because it occurs there 4 times. What percentage of students spend longer than the mode doing the experiment? So how many spend longer than 35 minutes? Well, you count what's above it. 1, 2, 3, 4, 5, 6, 8, 10, 11, 13. So 13 out of 20 multiplied by 100, which is 65%. Right, so you can see there, you have your answers on the next page. Okay. Example 6. Right, 30 students were asked to measure the length of a line with a piece of string correct to 2 decimal places. They were told that the line was between 1 metre and 2 metres. The results were set out in a stem and leaf plot. Okay, so between 1 and 2 metres, so 1.02, this would be here 1.02, 1.14, 1.17, and so on. Okay, so what is the mode? Right, well the mode is 1.32 because you can see there that 2 is there 4 times. Are there any outliers, anything far away from the others? Yes, there are outliers, 1.02, right, because that's far removed from 1.32, and 1.58 and 1.68. These are outliers. The modal class then, what's the modal class? It's between 1.30 and 1.39. Right, 1.30 to 1.39. meters, it has the most results. So that's the modal class. Right, this one here, this line here has the greatest, number of entries, so it's the highest frequency. Okay, so for a histogram with equal class intervals, the modal class is the one with the highest frequency. The mode is the middle interval value of the modal class. Right, so in a 50 kilometre speed zone, the Gardaí recorded the speeds of 60 cars to the nearest kilometre per hour using a speed detection radar. The results were recorded. Speeds then, you see you have them along there. Right, so draw a histogram and a frequency polygon. What is the mode and what percentage of cars broke the speed limit? Okay, so you do your histogram, you do your frequency polygon, and you get the mode. So just look, let's go to the next page. Right, you all know how to do your frequency. 0 to 10 is up to 2, 10 to 20 is up to 5, and so on. Now the frequency polygon, again, you go to the mid-interval value, so halfway between 0 and 10, so you put a dot at 5. Mid-interval value between 10 and 20, put a dot there at 15, 25 and so on, and you join them together. That's your frequency polygon. Okay, so the mode is the mid-interval value of the modal class. The modal class, therefore, is 40 to 50, right? The one that occurs the most often there is 40 to 50. It has the greatest frequency. 40 to 50 is the greatest frequency. Right, so what's your mid-interval value of the 40 to 50 modal class? Well, what's halfway between 40 and 50? It's an interval of 10, so half of 10 is 5, and added to 40 is 45. Or add 40 and 50 and divide by 2. 90 divided by 2 is 45. And the third question, you were asked how many cars broke the speed limit. So if the mid-interval value, the speed limit, what percentage of cars broke the speed limit? So the speed limit, remember, was 50 kilometres per hour. So what percentage of cars broke the speed limit? So how many cars were greater than 50 kilometres per hour? So you go back here, between 50 and 60 and 60 and 70. So between 50 and 60 is 10, and between 60 and 70 is 5. So that's a total of 15 out of the total of 60, and that's 25%. Right, modes of histograms and frequency tables, frequency polygons and modes.